Hey guys, welcome. Chapter 11 study guide. So let's go ahead and get started. Make sure you know all your volumes. It's going to be very important for the test. If you don't know the volumes, you're going to have a real tough time. But if you know them and you know the study guide, you're going to do great. So first of all, we have a cylinder. So volume of the cylinder is pi r squared times height. So it's basically finding the area of the base multiplied by the height. This is the full diameter, so we're going to take half of that to get our radius to be 7. So we get 7 squared times 18 pi. We always want to leave things in terms of pi unless I say otherwise. But so this time we're going to do 7 squared, which is 49, times 18. And then we're going to get 882 pi. Oh, sorry, no units on this picture, so we're just going to put units cubed. Sorry about that. Alright, so volume of a cone, first thing, it is the same as the one above, except for we're going to do 1/3. This right here over to the side, if you're not sure on the test, you can just ask me, but this is going to be a 9 squared times the height of 14. Evaluate these. 9 squared is 81 times 14. And we get this. And I like to evaluate these two guys together, so I'm going to take 1/3 of 1134. So 378 pi, and then we have the units on this one. And there we go. Volume of a prism is big B times H. You can choose what your base figure is on a prism like this one. We have a lot of different ones. I'm going to choose to use this bottom piece here as my base. So it's going to be the area of a rectangle is 8 times 23 times the height of 14. Essentially, rectangular prisms, you just multiply all the numbers together. And we get 2,576 cubic centimeters. Okay, so nice and easy for the first set. All right. Wait, did I do that right? Nope. There we go. I thought I skipped one. Okay, so on this one, our base figure is this piece right here. Okay, so what I like to do on this volume is big B times H. So a lot of times I'll put the height in right away. The height is the distance between the two bases, which is going to be 13. And then over to the side, I'm going to say, okay, how am I going to find the area of the base? The base is a triangle, so the formula is B times H. So I'm really focusing only on the blue part for this piece. Okay, so the base of this triangle is 9. Oops, wrong pen. And the height is 7.6. And then I'm going to take half of that. Okay, so calculate all that out. And I'm going to get 34.2. Again, that's the area of the base. So I'm going to plug that in over here and multiply it to 13. And I get 444.6 cubic feet. Okay, I'm going to do a similar thing here. This time my base figure, kind of hard to see on this, so if you're confused on the test what shape it is, I'll be more than happy to help you out. But this is actually a trapezoid. So we still have volume of a prism is big B times H. The height is the distance between the prisms, or sorry, the bases of figures, so this is going to be 21. And the area of the base is 1/2 H B1 plus B2. So if you recall, a trapezoid would be this, and sometimes it's nice to go ahead and just write the draw the trapezoid out, what it would look like right in front of you. So there's 90 and 90 here, so this is 8, 19, 24, and this is 11. Okay, so base 1 and base 2, we're going to get 19 plus 24. The height, we know the height is the distance between the two bases. They're both 90 degrees here, so we know that 8 is our height. And then 1/2. So we just evaluate all of that in our calculator, do the parentheses first, 19 plus 24 times 8, and then divide by 2. and we get big B to be 172, so we're going to put 172 right here. Multiply that to 21, and we get 3,612 cubic meters for that guy. Okay. All right, next, number 6, the volume of the square pyramid. It should say square pyramid, but we know this is going to be 1/3 big B times h. Again, my base figure is a square, so to find the volume, I'm just going to do 12 multiplied by 12, and the height is perpendicular right here, so that looks good. 9.1 and 1/3. And again, if you need to use a highlighter on the test, I recommend it. And I'm just throwing all this in my calculator and then dividing by 3, and we get 436.8 centimeters cubed. Okay? Alright. Alright, so this one's a little bit trickier. If you look, our base figure is a triangle on the bottom. Okay? However, this triangle is slightly different than the triangle we had in number 4. This triangle is an equilateral triangle, which means all the sides are congruent. So 8 and 8. So we need to find the height. To do that, we got to drop in a height, and it breaks this up into 4 and 4. And this right here is 60 degrees and 30 degrees, because the equilateral triangle, all angles are 60. That altitude cuts it in half. So we actually get a special right triangle here. So this is 30 is our x position, across from 60 is x rad 3. So we get 4 rad 3 for the height of this. So our volume equals 1/3 big B times h. I see my height is 11. But we need to find the area of the big B, which is 1/2 B times h. Again, this piece refers to the area of the bottom figure. So we're only looking at this triangle. The base is 8. The height we found to be 4 rad 3 and 1/2 times that. Okay? So half of 8 is 4. 4 times 4 is 16 rad 3. Okay, and we can leave this in simplest radical form if it all works out. And it won't. It'll leave us with a decimal, so might as well just go ahead and multiply the whole thing through. So 16 rad 3 times 11, and then divided by 3. And we get 101.6. We're just going to one decimal place on this video. Cubic meters. Alright, boom. A classroom has a globe with a diameter of 34. What is the volume of the globe? So again, just using our formula, we need to get the radius first. So we're going to take 34, divide that by 2. What is that? Is that 17, I think? Pretty sure, but you never want to make a slight mistake. I've corrected lots of kids who've got the wrong answer because they thought it was an easy math problem. They tried to do it in their head. Alright, so we got 17, and we're going to cube it. If you don't know where that is on a calculator, you're going to have to know. Okay, and when I do it on my calculator here, I have 17 cubed. I got that. So what I like to do is I like to multiply by 4, and then I like to divide by 3. And there we go. So 6,550.6 repeating. And I'll still leave that in terms of pi. And that's going to be in cubic inches. Alright, the volume of a cylinder is equal to 2,016 square centimeters, cubic centimeters, and the radius is equal to 12. Solve for the height. So what we got to do is we got to use our formula, pi r squared times height. It tells me my volume. And let's see, it tells me my radius, but it does not tell me my height. Okay, so what I can do is this becomes 144 pi times height, and all I have to do is divide this by 144 pi, Okay, that cancels out, so h is going to equal. And over here, these pi's cancel out, so I really just have to do 216 divided by 144. Hit enter, and we get 14. Don't have to do units cubed or anything like that. I can put centimeters on, though. Erica made 2 candles in the shape of cylinders. The first candle has a radius of 10 and equal to a height of 18. So let's go ahead and do that. The second is 9 higher, so I'm going to go ahead and just put, alright, this was 10 and 18. The second is 9 higher, so if I do 18 plus 9, I believe I get 27. It has the same radius. Okay, there we go. How much additional wax is needed to make the taller candle? So I got to use my pi r squared times height formula, and I can just go ahead and see what the difference is. So this is going to be pi 10 squared times 18. This one's going to be pi 10 squared times 27, and we'll compare those real quick. So 10 squared times 18, you get this pi. Over here you get 10 squared times 27, and we get this pi. And what we can do is we can go ahead and subtract those and see what the difference is. And if we do that, we're going to get our difference to be 900 pi. So how much additional wax? 900 in pi cubic centimeters. Okay. So that would be the equivalent of all this up here, I suppose, would be the 900 pi. Number 11. Woohoo, tricky piece right here, huh? Okay, let's break this into parts. Let's go ahead and we got first we got a cylinder. We'll find that, and then we're going to add it to the cone. Okay, so cylinders first, nice and easy. Pi r squared times height. If 20 is the diameter, then 10 is the radius, so we get 10 squared. And the height here is 6, so we're going to get 600 pi. Okay, so that's not too bad. Now this one, the cone's a little trickier. We got 1/3 pi r squared times height. Now I don't have a height here, and I don't know the radius either, so if we know from here to here is 10, the radius here is going to be 7. And we got 7, 8, so we got to use like some right triangle rules, so we got to figure out what this is. So 8 and 7, so we're going to use Pythagorean theorem over here. So 7 squared plus h squared equals 8 squared. And I'm going to evaluate that in my calculator. Okay, so h squared equals 15. So I'm just going to call h squared the square root of 15 because it's not a perfect square. We'll have to plug that into our calculator. Pi and 1/3. So this is probably going to turn out to be somewhat messy. We might have to evaluate the pi, but we'll go ahead and take a look and see what happens. 7 squared is going to give us 49. And then we're going to have to divide that by 3. Ooh, messy, messy, messy. Yeah, I'm just going to calculate this whole thing in my calculator at one time. Okay, so I'll show you how I'm going to do that. I'm going to get 7 squared, and I'm going to multiply by the square root of 15. And then I'm going to hit enter. Then I'm going to multiply by pi. And then I'm going to divide by 3. Okay, and so we're going to get 198.733. We're going to just keep it safe, 3 decimal spots. And then over here, we're going to evaluate this guy. And 600 pi is going to be a bit bigger number. And then we're just going to add those two together. Okay? So, doop-a-doop-a-doo, shooba-dooba-doo. And our final answer is 2083.688 if you go 3 decimal spots, cubic feet. So that one's kind of a tricky question, but we can still get it. Find the volume of one, find the volume of the other. We call that a composite figure. All right, home stretch. All right, The prisms below are similar. Find the scale factor, surface area, and volume ratio of the larger. Well, remember scale factor is A to B. Surface area is A squared to B squared. And volume is A cubed to B cubed. So I really just got to find what is my scale factor first. And you can pick how you want to do this. It didn't say, let's say ratio of the larger to the smaller. So we want large to small. So 18/4. We already know they're similar, so I don't have to check each side. I believe 2 goes into both. That's 9/2, and I think we're done. So that's our scale factor. Okay, to get from here to here, we just got to square both terms. So you get 81/4, and then we cube each terms, and unfortunately Mr. Smith doesn't know 9 cubed, but there it is. But Mr. Smith does know 2 cubed, which should be 8. That's simple, huh? Okay. Looking at this next one, the scale factor, 2 similar cones is 8/7. What is the surface area ratio and the volume? Well, if 8/7 is our scale factor, we just have to do the same thing we just did in the last problem. So I need to square them and cube them. Okay, and again, if you don't know what the squared of them are, I know square off the top of my head. That one's pretty easy. Cube, not as easy for me. So I got 512, and it looks like I got 343. Okay. And last one. A is similar to B. If the surface area of A is 80 square inches and the surface area is 245, okay. Find the volume of A. So we did A over B just to keep a reference point. And this was, this is going to be kind of confusing. I wish I didn't do that. Let's do solid A over solid B. There we go. But this is area, so we're talking about A squared, B squared. We want to find the volume. The volume of A we don't know over the volume of B we do know. But this is A cubed to B cubed. These are not the same, so I can't set them equal to each other. So I would like to square root them to get rid of that, and cube root these to get rid of that, and that should bring us to the appropriate measure. Here's the problem. 80 and 245 are not perfect squares. So that sucks. Fortunately, we can reduce the fraction. So we're going to go ahead and turn this puppy on. 80. Here's our secret button right there. Looks like a little L. 245, and let's see. Wow, 16/49. It's like magic, you know. Okay. These are still squared. Don't forget that. All right. So the square root of 16 is 4/7. And this is what I kind of leave this part blank here because I don't want to cube root these, so I'm just going to cube the whole thing. That will break this down to here. But if I cube one side, what do I have to do the other side? I have to cube it as well. Okay? So 4 cubed is 64, and 7 cubed, I believe we just did a second ago, and I think it was 343. And it was. And we cross multiply here, and we get 343x equals, oh gosh, a huge number, nothing we can't handle, and divide. And looky there, we come up with a decent number. And last thing I want to check on this piece here is, notice I was looking for the volume of A, and notice how A is smaller than B, and so I want to make sure this number is smaller than that number, and it is, which makes me happy, which means I must have done at least something right, you know, at least something right. So I think this is the part of the video where I tell you something weird, so you can remember it and maybe use it for extra credit. Or something like that. So this is what I'll say. I'll say, dog.